Hi, today we're going to do number 3, longest substring without repeating characters. So we're giving a string S, find the length of the longest substring without duplicate characters. So we can see at this example here, we have A, B, C, A, B, C, B, B, and output 3 because we have this string of A, B, C, that's the length of 3 that isn't duplicated. If we were to go longer, A, B, C, A, that wouldn't count. But also CAB would have worked as well, and BCA, and all of them has a length of 3, so that's what we return. Here, B is all B's, so B will be length of 1, that's non-repeating. And here, we have WKE being a length of 3. So one way we can do this is using brute force. Generally, you can do that when checking all combinations. So we have to loop through S, and then in this loop, so we need a way to keep track of unique values or characters. So the data structure that should come in mind is a set. So we create a set to keep track of unique characters, and then do another loop, say a nested loop, and here check if value is in the set. So let me say it differently, add the value the set if doesn't exist, and outside of this loop, so, and then we need a way to keep count, right? So we can create a count variable and set it equal to 0, and here we add the value to it, okay? And then once we finish this loop, we have all the unique values inside the set. So update count if the size of the set is higher, and we can just return count at the end. And this way, the time complexity is going to be O of, you could think of it as n squared, but in this case, we can do n of n times m, where n is the length of S, and m is the number of unique values that we can do. And then the space complexity, it can just be sorted to O of m, because m is the number of unique values we can do, and that will be the size of the set. So how else can we do this? How can we make it more efficient? And another technique is using a sliding window. Since we're doing a lot of repeat work when we're doing a nested loop. So here we do the same idea, we create a count. And then we create the set on the outside, create set. And we start with the left pointer, and we start with a 0 index, and then we loop through with the right pointer. And here we can check while the set has the value of right pointer. So here we're kind of doing it backwards. We're kind of thinking about the edge case where there's a repeat. Like we see A, we add to the set, B, we add to the set, C, add to the set, and that's what we're going to do in a loop. Then A, once we get A, we want to delete. The left pointer will still be here, so we want to delete that. And we want to keep doing that until we get to a unique value where it's not the same. So that's why we do a while loop. And then inside this while loop, you set delete value at left pointer, and then we want to increment the left pointer, so we're not in an infinite loop. And then otherwise, as we do this this loop, we want to add the value to the set. Add right pointer value to the set. And now we can update count to the max of count, or right pointer minus left. And since they're inclusive, we want to add 1 into it. And then we just return counter. And here, the time complexity, we're just doing 1 loop, which will be O of n. And then the space complexity, so the space complexity here, since we are doing a set, and the set is also going to store only the unique values, so it's going to be O of m, where m is the value of unique values inside this set. So since the sliding window is a more time-efficient algorithm, we'll go with this way, but I'll show you both ways. So we create a count variable, and that's what we're going to return. And now we create a set equals char set. No, that's why I mean to name it new set. And we have a left pointer index. Now we do a for loop, and usually we do I here, but we can call it right. And it starts off as 0. Right plus right is less than s dot length. Right plus plus. And here we do a while loop, while s dot while char set dot has s right. We delete char set dot delete s dot left, and we increment left. And now we add the right value. Now that we clear the window, if there's a duplicate, we can add the value to the set. So char set dot add s dot right, and now we can update the count. Count equals math dot max count, or right minus left plus 1. Great. So now we can do it the other way, the brute force way. So we're going to still keep this idea of keeping an account, but now we do this for loop. And now we create the set. And I guess we can add the initial value of I into it. So now we do another nested loop equals j plus 1. So we'll look at the next one. J is less than s dot length. J plus plus. So if char set dot has already has s dot j, we want to break out of it. Else we add it. And now here we can update count. count, or the size of char set. So this would be j, and this would be I. Great. So that's another way we can do this. So we can either do a brute force approach, where we look at each value, and then we loop again, adding it to the set, and then we know when it's done. If it hits a repeat, we break out of it, and then find the size of the set, or else we keep adding it until that happens, or we finish the loop. Or we can use a sliding window where we use a left pointer and a right pointer, and then we're going to keep sliding it, we keep moving the right pointer, and then if we see a duplicate, we delete the left pointer value and increment the left pointer. And that's how you solve this problem. Thank you.